Hello everyone, we are going to look today at geometric progressions, also called geometric sequences. So we studied before arithmetic sequences, where the difference between two consecutive terms is the same. For geometric progressions, the ratio between two consecutive terms is the same. Like, for example, so let's look at the first example. Every term is obtained from the previous one multiplied by 2. This makes the sequence geometric. In this case, u1 is 3 and the common ratio is 2. We generally use the letter R for the common ratio, same as we use D for the common difference, but it doesn't really matter. Look at the second one, times -1/3, times -1/3, and so on. So the first term is 3, and the common ratio in this case is -1/3. Okay, so the question is, how do I find the general term, the nth term, directly? Let's look at the pattern. If the first term is called u1, the second term will be u1 times the common ratio. And then the third term will be the second term times the common ratio, or if I'm to write it in terms of u1, will be u1 r squared. So u to the power of 4, I'm going to multiply another r. And you see how un will be u1 times r to the power of n minus 1. And that's a general term of a geometric sequence with the first term u1 and common ratio r. Please pause the movie and try this question yourself. Not only decide if they are geometric progressions, but also try to find the general term in the case we have a geometric progression. In fact, I'm going to do a bit more than the exercise asks, because see, it's written as a geometric series. So if I'm to use a sigma symbol, I'm not required. I just want to practice a bit. How am I going to write it? Is sum 5 times 3 to the power of n minus 1, and starts from 1 up to infinity, because I have infinitely many terms. As you see, for question B, I was not sure if it's a type or not, but if the sequence is as written here, is not on geometric progression because of that term here. Whereas if I change it like this, it is with a common ratio of -1/2, and that's how I can write it as a series using the sigma symbol. So the big question now is, how do I find the sum of the first n terms of a geometric progression? And the sum is called geometric series. Remember, I can use S or another letter. So I want to find u1 plus u1r plus u1r squared plus up to the nth term, which is u1r to the power of n minus 1. So I'm going to do a no words proof. Just follow and try to understand. Now I want you to look at the formula. let's interpret it. The sum of n terms, n is a number of terms, is the first term in the sum times 1 minus ratio to the power of the number of terms. So n is a number of terms. It's not necessarily the letter n that sometimes has different meanings. So n is a number of terms over 1 minus r. And you see why I impose a condition r is not 1, such that I can divide by 1 minus r. In the case when r equals 1, it's a trivial case, because your sequence will be, if r is 1, u1, 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 the constant term, constant sequence. So it's not really interesting. That's why this condition, it's fair.